model we have the least AIC and SIC? 611. Okay, so we will consider this model 611. Okay, fine. So why we selected 611? Because it has the lowest AIC and SIC values. Okay, so that is the model which comes out with the least error, right? Least error compared to the other model. Okay, fine. Now, what is the next step? So we are going to use that model for the forecasting. Okay, so now I'll share the screen. I'll do with the EViews, and here you have to do a small changes here with your the structure of the work file. Okay, so I will do that. Just follow the steps in EViews. Okay, let me share the screen. I think it is in the shared already. The screen is visible. Okay, fine. Let me close this equation. I am deleting all the equation. Okay, yeah. Just see the screen. You can see the variable here. Okay, so what is the number of observation here? 170 observations, right? Okay. Okay, so what I will do is I'm going to file. Yeah, you can see here the checked proc. Okay, look at the proc. Click the first option. Click the first option. So how many number of observations? How many observation here? 170. So I'm going to forecast some 2 periods ahead. 2 periods ahead. Okay. So you want me to repeat again? Okay, I'll close this. Keep this page. Go to this page where you can see the variable. Go to process. Click process. You resize your number of observations because the existing one is 170. So what I'm going to make 172. Just 2 observation. Yeah, 2 days ahead. Or you want to make a 175 also up to you, but don't go for the long-term forecast because 5 days. So I'll go with 172. Click OK. Yes, continue. Okay. Now go to estimate. So which model is the best model? Returns. C AR 611, right? Okay, 6 MA 6. Oh, sorry, 1. Okay, so you know that no, it is 170. What is the sample? 170. Why it is 170? We call it as in sample observation. So in sample observation. In sample means historic observation. So the observation based on the historical data. How many data? 170. We are not going for 172. True observation is called as out of sample observation. Out of sample observation, just for your information, which we are going to use the last 2 observation for the forecasting. Okay, so let me go with this is called as in sample estimate. Technically, this is in sample estimate. Click OK. So we are talking about this result, right? Yes or no? Previous result which you got, this one same. Okay. So you can see here 170 observation. Have you got this? Okay. Now we are going to forecast. Click the option forecast here. Forecast. You can see the forecast option here. So what is the forecast here? Returns forecast. Returns F. Can see returns F. Okay. You can see there are two options, dynamic and static. Okay, dynamic and static. You can use both. But here, since I'm going for next one observation or two observations, okay, go with the, we try, okay, go with the static. Go with the static. Okay, we'll see. Go with the static. Come, madam. I'll come. You got this one, no? Either click static, you will go with the static and see, but because our short-term forecast, no, 1 day or 2 days. Click OK. Click OK. Minimize. Sorry. I mean, you minimize this one or just no. Yeah, go to this page and see. Just a minute. Okay, I'll come back. Forecast. Go with the 171 then. One static, we'll see. Yeah, we'll go with this one then. Okay. Turns F. 25. Yes. Yeah. Okay. Same thing only. Anyway. 24 and 3.61. Okay. Listen. I'll repeat the step again. Okay. So anyway, give the same result only. I just tried. Go to, again, I'm repeating. Go to estimate. You got this right? You got this right? Previously, this is the estimate of ARIMA 611. Now, what I'm doing, I'm going to do the forecast. If you do the forecast, anyway, you can go with the 172 or you can go with the, no, I will go with 170 also. 171. So 171 and 172 because only two no observation I just inserted, right? If you go with the static, try with the dynamic also. I'll go with the static. Click OK. Then just minimize this. Open the returns and you can see two values which I got is these two. The last two. This is the forecast. Two observation which I have forecasted. If you want to compare and see how to do it, just click close it. Open. Group. View. Do a graph. Don't do anything. Just click OK. And see here. So both are same. The problem is, look at the last two values here, which I couldn't see. Yeah. The last two observation, which I could not able to see, the last two observation which we forecasted. Okay, otherwise, just, yeah, I'll close this. I'll plot the graph of this. You can see, go to view, graph, click OK. Okay, anyway, the last observation which I could not able to see is nothing but the forecast of the last two observation. Okay, you understand, no? You got it, no? Otherwise also no problem. You can no go with 1 to 172 and you get the same value which I tried. And so can I repeat it? Can I repeat it again? Can I repeat it again? Have you resized your work file? 170 become 172. That step you have done it, right? Madam, that you resize the work file, right? So go to estimate. Here. No problem. Go to the, just let me close this. Returns. Space C. AR 6 space AR 1. Sorry, MA1. MA1. Okay. So 170 observation. This is in sample forecast. Click OK. You got this, right? You got the output, right? With this, go to forecast. So if you use this same 172 also, fine, you'll get the last two value, forecasted value. Or you want to change it like 171 space 172 also, fine. Use a static forecast. Click OK and minimize this and click the values. To see the table sheet. Yeah, sheet. Last two values are our forecasted value. Negative. The market is going to be negative. The price is going to be, returns is going to be negative, and slowly it's going to turn it as the positive. Okay, 3.61. So this is about the forecasting of next two period ahead of using ARIMA. Okay. Madam? The graph is not required. Just look at the last two value and take it and go ahead with the table. But the thing is, mostly ARIMA is used for the model comparison. You know what is a model comparison? No. Suppose you are using OLS and ARIMA. No, don't go for in between any. No, that means a small technical issue will be there. That should be, that's the original file. And F returns F you have to open. There are two files automatically out of sample created, no? When there is an option in the box, insert out of sample observations. By default, it is there. It is there, no, it will be there. It will be there. Returns F. Yeah. Last two values are the forecasted value. Actually, one more information I'll give you. This model has certain limitations. Because always there will be some error, right? Always there will be, any model you take, there's always some error. That's why there's a value of AIC and SIC. They try to minimize the error, but there is always some errors are there. Why? Because we are regressing, correct? No. So we are constructing the model in a way that, in such a way that yt is a function of yt minus 1. Correct? No. So there are other variables should be incorporated. We call it ARIMA X model. ARIMA X model. What is ARIMA X model? We are bringing the explanatory, the other variables into the picture along with the lag variable. But you are using only the lag variable. There always error will be there. Okay, but when this ARIMA will be effective, I'll tell you, please. Sir, I have 5 model in hand. Which model to be effective comparatively, relatively? Sir, I have estimated ARIMA. For example, I'll tell you. You estimated OLS, simple OLS, and you forecasted. Then again you go with the ARIMA. So when you compare which model is the best model in forecasting with least error. So in that model you can come out. Yes, ARIMA is relatively better than the ARIMA is better than the OLS. So sometimes you use GARCH model. We start ARIMA, GARCH, and eGARCH model. Then we can say which model is the best model in terms of forecasting. Sir, I will go with ARIMA and the machine learning for the forecast. So which model is the best model? Compare whether ARIMA model is best model or the algorithm models. No, algorithm based models are better model. Yes, I have seen articles published. We started with ARIMA. Okay, anyway, this is about the forecasting exercise using the ARIMA model. Okay, fine. So now we'll move to the next, the VAR model. VAR model, the extension of AR, VAR model, VAR setup. I'm going to explain a VAR setup. Before that, let me use the procedures. Very important, which is connected with there is a flow. Okay, so I told you yesterday, what is the starting point of time series analysis? First, what we'll do with, suppose you want to start the econometric analysis. So what is starting point? You have a variable with you. What is starting point? What is starting point? Suppose you have two variables. Let's say x, y. Okay, I'm using the board. X, y. You have two variables. What is starting point? Where you start? You want to apply the econometric model. Forecasting means you can do directly. Even forecasting also has starting point. You want to forecast X and Y. What is starting point? Okay, very good. Unit road. So starting point, correct? No, that's what okay. Suppose I want to find out the impact of X on Y. What is starting point? What is starting point? I want to see the impact. I want to examine the impact of. First one is forecasting. Forecasting, she said no. Yes, sir. We'll go with the unit route. Yes. Forecasting. What is starting point? ADF. Unit route, right? Stationarity. Okay, very good. The stationarity or stationary concept. Okay, very good. Stationarity. Forecasting. Second one. Sir, I want to examine the impact of X on Y or vice versa. So endogenous, vice versa. So what is the starting point? Where you start with? Yeah, you start with the correlation, then again go with the stationarity. Very good. So I'll go with the stationarity. Stationary. Whether it's a correlation matrix or whether it's a descriptive, starting point for the econometric procedure is. Third one, I want to see whether the X leads to Y or Y leads to the bivariate setup. The bivariate setup, or we call simultaneous equation model. where I'm going to estimate simultaneously. So this concept is very important. Okay, so that I can easily estimate the model and should. The estimation is easy. So please. So we want to find, see, this is the third object, causation. Whether X causes Y, to examine the X, whether X causes Y or Y causes. Example, no, I told a simple example. You take the GDP is equal to alpha 1 plus beta 1 FDI plus U. UTRU. Now, when you attract more FDI inflows, which leads to GDP. Correct? No. The other way around. Now, this is one way. This is equation 1. Now, the theory says it's not only one way. There's the other. There is the other way. What is the other way? FDI is equal to alpha 2 plus beta 2 FDI plus V. Sorry, GDP. GDP. Correct? No. So here you cannot estimate individually. You have to estimate jointly. That is what we say. It is simultaneously. Simultaneously, you have to estimate both. That is what all these VAR setup says. VAR or VCM setup says. So we are going to estimate simultaneously these two. Otherwise, if you go with the estimation of one equation, see here, what is your observation? Independent variable is influencing the dependent variable. And the second equation, that the dependent variable of the first equation is acting as a independent variable in the second equation. Please. So there's a problem called endogeneity. What is endogeneity issue? This is endogenous variable. Why? This GDP is, you can see in the both equation. This is acting as a dependent as well as independent. The endogenous variable, not exogenous variable. Understand? No. Suppose I'm bringing here plus. Let's say here I'm bringing beta 3 as exchange rate plus UT or U, whatever it is. Now plus, here I'm giving another variable which we called as, yes, we can, there is a possibility of estimating this, plus beta 4, I am bringing here INR, rate of interest, plus V. So here there are two exogenous variables. What are the exogenous variable? Exchange rate and INR are exogenous variable, because you can see independently in each equation. There is no connection of this in the second equation. There is no connection of INR with the first equation, which we call it as the variable which is acting outside the system. I mean exogenous variable. Now here, which is endogenous variable? GDP and FDI. Correct? No, because which is acting as a dependent as well as independent. Now come to this model. So what you supposed to do? UV or U1, U2, no issues. 1, 2. I'll bring the lag term later. So GDP is influenced by FDI, and the FDI of T is influenced by GDP of. Simultaneously, you have to estimate. If you want to go with only one equation, so which you will end up with the problem of the endogeneity, with specification error, which is specification bias. So we have a setup called a VAR setup. I'll explain later. We have to simultaneously equation model. You have to estimate it simultaneously. Okay. So what I'm saying, that is what I'll come to the causation. This is a causation. This also leads to, this is a example of the causation model. What you are going to see, whether X leads to Y or Y leads to, whether FDI leads to GDP or GDP leads to FDA. Just for example, I have taken. So what I am saying, whether the first objective or second objective or third objective. Third objective. Okay. So what is the starting point? You have to start with the stationarity concept. The variable should be stationary. Variable should be stationary. Okay. So you understood now, whatever the objective with respect to your analysis, the objective, that should be, starting point is the stationarity. Okay. So let me start with the stationarity. So x and y, there are two variables. There are two variables, x and y. So what are you supposed to do? You have to first check the stationarity condition, whether it is I of 0, x, y. What you have to prove? You have to see whether it is I of 0 or I of 1. So starting point. You bring, no, you, if you want, sir, I want to know, find out the correlation between the independent variable, yes, correlation matrix, yes. Sir, I want to go with the descriptive statistics, yes, fine. Sir, I want to, publishing article, I want to go with the graph to look at the behavior of the pattern, whether it's a seasonality or there is a break, any break, a switch I'm talking, switch. You can show graphically. That's up to you. But you have to start with the stationarity concept, first one. Now, if two variables are stationarity at level, to understand, no, x and y, two variable are stationarity at level. Okay, so you have to do estimate. So what is the estimation? So estimate var, which data you have to use? Level data, which is the raw data, or which is the natural logarithm. So level data, very good. The level data. So we are using the data of I of 0, integration of order 0 for the VAR model. Vector auto, one by one I'll explain what is VAR, what is it. So vector autoregressive model. So this is the econometric procedure. It's a beautiful article. I'll forward. I have some articles I forward. Clearly they will explain about what type of models could be used. It's based on the level form, first difference form. Okay, one is VAR. Okay, fine. The level data. Next, and in fact, one more thing I want to tell you, and this level data which you are using, correct? No, and this VAR of, this is long run. This is interpreted for the long run. Please try to understand. This VAR we are estimating, use the level data, is for the long run. In economics, no, we usually classify the long run impact and short run impact. Please. So we'll go for this is long run information. That means the data which you have consists of only long run information, not the short run information. This is the flow, the econometric of procedure. Also flow. Next one, let me go with the next one. Let's say x, y. So this is the integration of the integration of order 1. So most of the times, the second condition will be applied. Go with what you're supposed to do. If this is the case, your data consists of both long run and short run information. When your data is stationary at first difference, both are at I of 1, Your data information, no, your data consists of what type of information? Possibility. Both are both long run and short run information. So in this scenario, what you have to do? You go for applying co-integration. Co-integration. When the data are integrated of I of 1, then the two variables are co-integrated. Okay, so this is according to the Engel and Granger, no? The Engel and Granger co-integration theorem. We call it as like Engel co-integration theorem. Engel and Granger co-integration. Two variables are integrated first order. Okay, so it consists of the co-integration. There must be the co-integration relationship between two variables. What is the co-integration? Co-integration long run relation. Okay, so I told you the data is in the same order. It consists of the long run and short run information. So you can use the co-integration. Go for co-integration to confirm what? To confirm the long run relationship between two variable. Yes, it's a co-integration. Long run relationship between two variable. Then, sir, what for? There is also short run information. So how to go for the short run information? After co-integration, go for VEC model for the short run. For the short run. So co-integration for the long run and VEC model. What is VEC model? A vector error correction model. Vector error correction model. If the two variables are co-integrated, then there must be the error correction representation of the data. Okay. So as per the theorem, which has been proven already, we're just exercising that. Okay. So this is the flow, co-integration and vector error correction model. So co-integration confirms whether two variables are related in the long run or not. That's what, very simple. Okay, so co-integration. After co-integration, go for examine the causation between two variables x and y using vector error correction. It's simple flow. There are another possibility. This is possibility number 1, capital A, and capital B, second possibility, when you are dealing with the financial variable or the macroeconomic variable. The third one, C. The question comes, sir, when the variables are integrated, especially integrated in the mix of the order. Okay, so x, y. So one is I of 0, the other one is I of 1. So what to do? So here also there is a model. Okay, so which is suggested by, propounded by the Pesar and Shin and Pesar in the year 2003, Pesar and Shin, which we call it as, again, you can also go for co-integration. Latest one, co-integration, long run, impact, and also you can use it for, you can also go with the VEC. VEC means error correction model. Error correction model in a VCM framework. Okay, error correction model. This is for VEC model in a short run. Okay, so this is the latest one. Usually, if you go with the time series workshop, they will start with the first two, because most of the variables are integrated in the same order. Either it will go for I of 0 and I of 0, or they will go for I of 1 and I of 1. Maximum will go I of 1. So the data, when we know the research started to get the econometrician start to analyze if there is what will happen when there is a mix of what a solution. If there is a mix of the order of integration, then it has come out with certain advantages, which we call it as ARDL. These two framework, what I told you, these two model is based on ARDL. What is ARDL? ARDL approach. What is ARDL approach? Autoregressive distributed lag model. Autoregressive distributed lag model. Understand, no? The last one. That's it. But here also, there's another question, sir. If it is I of 2, we can't do anything with I of 2. ARDL model, no. It has certain properties. If you come out with one is I of 1, the other one is I of 2, then again it fails. You can't apply the ARDL. So here also there is a condition. It's a combination of AR integration of 0 and 1. The maximum variable will be either it will be 0 or maximum it will be 1. So these are very important. Very important. Okay, so here also we can go with the long run and short run. Okay, fine. So the first one is about the VAR model. The second one is about the co-integration and error correction model. The same thing we can apply for, the same concept we can apply in a ARDL through the same, the co-integration and error correction model also estimated using ARDL approach. Okay, when, what is the condition? When the order of integration are mixed. What's the mixed? One is in I of 0, the other one is I of 1. Now, this is about the time series analysis. This is the flow. So, one by one, we'll see about. Okay, so we are going to see one by one. The first one is about VAR. The second one is about the co-integration and error correction. Okay, so we'll start with VAR. VAR is also used for long run and short run. Long run and short run. I have seen some article without co-integration, straight away they use a VAR model only for the short run. I have seen monetary economics. Demand for money. Especially the studies, there are a lot of studies with respect to the demand for money. Okay, so they use the impulse response function or VDA, variance decomposition analysis, with respect to the supply side shocks and the monetary side shock or the demand side or whatever it is. So they use directly the VAR model without going for the procedure of co-integration. Okay, which is now published in the standard journals. Okay, so here, but this is an econometric procedure. What I'm saying, this VAR also used for long run and short run. Okay, fine. So let me go with one by one. First, let me explain about the VAR model. Have you noted this, right? So, ARDL model. Third, no, I mentioned. That's what, no, I have 1, I have 0. Anyone can be 1, and can be anyone. It doesn't know only stick to x and y x also, other way also. Okay, first we'll go with the vector autoregressive model. VAR model, vector autoregressive model. So let me go with the specification. Yt is equal to alpha 1. How many variables required here? Two variables, because I started with x and y, right? Any example you can take, respect your area of x and y. So y is equal to alpha 1 plus beta 1 xt minus 1 plus beta 3 yt minus, if you want to keep yt also, it's fine here. So yt minus 1 plus ut. u1t, okay, ut, u1t. There's one more residual. Okay. This is in AR setup. You know what's AR setup? AR setup. What is AR setup? Yt is a function of yt minus 1. In fact, you can see here, there is one more explanatory variable here. So xt minus 1. The lag term of the one more dependent variable. So what is another dependent variable? Xt is equal to alpha 2 plus beta. Okay, this is beta 2, I'll make it. Beta 3 yt, we want to bring it here. Yeah, okay. Yt minus 1 plus beta 4 xt minus 1 plus u2. So this is the bivariate. It's a bivariate. Okay, it's a simultaneous equation. Var setup. Understand, no? Got it, no? So here, which coefficient is important here for us? Which coefficient is important here? Yt, the function of xt minus 1 and yt minus 1. Which one is important for us? Xt minus 1 or yt minus 1? Because we want to find out the impact of the x on, very good, x on y on x on. So which coefficient is important for you? You have to know, interpret in such a way. Here it is beta 1 or beta 2? Beta 1. Remember, beta 1. Then the second equation. Yeah, beta. No, not beta. Beta 3. Understand, no? Remember, because there is a walled F test. Walled F test also is there, which is based on this framework. Which coefficient, is very important. That's we have to be very clear in this. So here beta 1 and it is beta 3. Okay. If xt beta 1 is significant, what are the inference? Okay. And before that, okay, significant. Okay, tell me. Beta 1 is significant. So what are the inference? This is war model. Why war model? We are going for the, let's say, causation. So when beta 1 is significant, so what are the inference? The lag value of x is influencing. Correct? No. So what is the inference? X causes y. Please remember. X causes y. Okay. Now come to this is first possibility. Come to the next one. When this is significant here. No. Yeah, this is significant here. What are the inference? Look at jointly. Simultaneously. Look at inference, I want jointly. Second inference. Beta 1 here is significant. Beta 3 here it is significant. So what is the inference? Two-way causation, which we call it as a bidirectional relationship between. So beta 1 and beta 3. Understand, no? Then third one. Sir, when y leads to x, and here y leads to, correct? No, y leads to x. You can't see the significance here. So third one is y leads to x. Suppose beta 1 and beta 3 both are insignificant. Both are insignificant. Tell me. Independent. So 4 possibilities are there from var output. There are 4 possibilities of var output. The short form of var is nothing but Granger causality. GC. Granger causality. The advantage of var is you can see the coefficient. But in the Granger, you can see only the F value, F statistic. To find out whether the X causes Y, Y causes X, or 2A, or both are independent. Understand, no? Got it? This one. These two. The exchange rate leads to export. Correct? No, analyze the theory. The exchange rate leads to export, whether it is a depreciation or appreciation. Usually we say the depreciation of the currency, right? Against the dollar will go with the increase in export, right? Now, the other way also possible, or the other way. So here, the exchange rate leads to export. The other way, the export leads to, find out. This to be? No, keep this x, say y, and keep this as x. Now, other way, I'm making this is x and this is y. When this is possible, this is also possible. Sir, when y causes x and x is also possible. Depends upon the statistically significant coefficient. The statistically significant coefficient. Now, third possibility, sir, two-way. Bidirectional, which we call it the bidirectional. What is the fourth one? What is the fourth one? This also go. The another way also it will go out. So no relationship, independent of each other. See, a best example I'll tell you. That's what I'll take this example of. Initially, the studies, my area. Yeah, you look at this case. Look at this case. GDP, the economic activity, right? Yeah, the FDI leads to GDP. Correct? When the policy formulation, the economists are into policy making decision, whether to attract more FDI inflows for what? To improve GDP. Correct? No. If you see India in 1990s, there's a great question mark. We are very, 1990s I'm talking about. After 1991, LPG, We are really worried about whether to attract more FDI inflows or not. Understand? No, before 1990, you see there is we started attracting a lot of stringent policies are there. After 1990 globalization, we started attracting the FDI inflows. There is a question raised whether these FDI inflows leads to economic activity or not, the GDP. Correct? No, this is so FDI. This the empirical question raised. You say it's a research question. You say the empirical research question raised. This hypothetically it has to be tested whether this attracting FDI inflows leads to GDP. Okay, that is one way. Then later, the question raised. Sometimes the FDI inflows in a country determined by economic activity, GDP. GDP usually used as a proxy to measure market size. Our Indian market size is huge, which is represented by not population, represented by GDP. Population is a proxy which cannot be used to measure the GDP. So GDP is represented by GDP measures the economic activity or the market size of the country, any country. When the market size is huge, what happened to FDI flows? When market size is huge, what happened to FDI flows? More FDI. What is the reason? They want to capture the domestic market to utilize the labor. Correct? No, and to make the profit by selling to produce the food. That's what we see the MNC's concept, right? MNC is a form of FDI, routed through whether it is the RBI automatic route or the Secretariat of Industrial Assistance. The portfolio comes to SEBI. Leave it. The sources of FDI. Now, the question raised, this is initially the question raised, no FDI leads to GDP. Now, later, we start that yes, it is the other way around. The GDP leads to FDI. This is a simple example I used to. You can compare with you. These are all in accordance with the theory. These are all accordance with the theory. And there are the classical theory, endogeneity theory. Behind this, what I'm explaining, there is a DLO approach. There's an approach called Dunning's model, an approach long back. ILO approach. ILO. So what I'm explaining is based on all theories or the statement put forth by the economist. Okay, so this. Okay, so what is the possibility? FDI leads to GDP and GDP leads to FDI. Correct? No. There is also a possibility two-way. So GDP reinforcing. What is the reinforcing, right? Mutual. The feedback relationship or the bidirectional relationship. So that is also possible. Sometimes the relationship is independent. I have seen studies which proven, I know the studies which proven there is an independent relationship between FDI and GDP. So how hard? No, you are maximum you try to attract more FDI into the country, but doesn't contribute to. Both are independent. Both way we test independent. There is one study that our scholar, senior scholar, Dureraj published in long back, 1996 he has published in Indian Journal of Economics, University of Hyderabad, not in University of Delhi or Central University. It has come out with the article, Indian Journal of Economics. Nice one. So there, we found our Central University scholar, long by 1995 scenario, I'm telling. Both variables are found to be independent. Both variables. Nice study, actually. He used the Granger causality test. Still, I could remember. So, independent relationship. So, what are the possible cases? One is one way. This is one way. One way causation. This is also one way causation. What is here? What is here? Two way. What is the last one? Independent. So, GDP and FDI are independent. All four possibilities are there. with respect to this two variable. You can take the other way, I mean, the variables of your research. Okay, 4 possibilities. So look at the VAR framework. Look at the VAR framework. This beta 1 here and here beta 3 are very important. It's a lag variable. I'm not. You want to consider lag. See, we are consider lag here and not required, because since it is very specifically used for the causation. Okay, fine. So now this VAR model, if it is conducted using log, I told you, go back to the condition, 3 conditions what I told you. The 3 conditions. The first one, let me go with ln. What is ln? The log of yt, log of xt, then log of yt minus 1. Here also same thing. Log of xt, log of yt minus 1, and log of xt minus 1. So this is the VAR model, which is interpreted for anyone? Don't bring it that way. Which is interpreted for what is the LR? Long range. Since the log value, the raw data which consists of the stationary data level, which consists of the long range information. So please remember, this is used for short run, the VAR model, right? Short run interpretation, VAR model for the short run, long run model. So VAR model, that is the long run, used for the long run. Now let me go with one delta. This is, if I'm using ln delta, or go with the delta, no problem. Beta 1 delta. So this model is for long run or short run? This model, delta. This, no. Both will be, specifically here, here go for short run. VAR model for the short run. VAR model for the short run. Because the long run, if you look at the long run, there is no loss of information, which consists of long run information. If you go for short run, we are differencing it. And when you are differencing, there is a loss of information. What is the loss of information? The first variable will go off. And further, you are reducing the variance, the data, which highly subject to the short run, not for the long run. So this is the property of the time series analysis. Okay, to understand. So what we will do is, I'm going to estimate this using 2 variables. I'm going to estimate this. First, we'll do the VAR model. Okay. And there is also the short form of VAR, which we call it as, note down, GC. What is GC? Yeah, Granger causality test. Granger causality. Granger causality test. Okay. So we will estimate this VAR model. How to estimate? You learn this, how each and every model will be estimated. Okay, at the end, you know the procedure based on the integration of the data. Okay. So can you go for VAR model first? Okay. So I'll do it practically. So how to estimate VAR? And go for the GC. What is GC? Granger causality. Okay. I'll give a data. I'll share a data now. So we'll estimate and see. So, but what is the starting point? Still don't forget. What is the starting point? We'll start with the stationarity test. Okay, that's a basic property, the fundamental properties of the time series analysis. Okay, fine. So I will share the data. Just conduct ADF and let me know the result. I'll go with the flow. Okay, fine. Everything is based on the OLS framework. So all these models are based on the OLS framework. What is the OLS framework? No, the least square method, the regression model. No, how you will differentiate it? No. That's what, madam, you can't differentiate it. See, when you have to change the model, see, everything you should see first. Tools, calculator. When you use the calculator, I have a calculator. Since I have a calculator, I will try with the subtraction. Since I have a calculator, I will try square root. Since I have a calculator, I will try with the addition. Understand? No. Since I have a calculator, I'll go with the standard deviation. Don't do that. Don't do that. Why we are using calculator? Why we have a calculator? Very simple. The purpose. My purpose is here to add or divide. You have to take a call. Not I am having a calculator, I want to try these models. Wrong. We end up with a problem actually. Calculator, I have a calculator in the mobile phone. Very simple. I want to do your objective to be fulfilled. Sir, I want to do a regression model. You have a Excel. You can do, right? So look at the software as a tool. The models as a tool. Understand? No. Since I have calculator, why can't I try addition? Try. Why can't I try subtraction? Why can't I try the division? Logic. So here, what is your first identify your objective? See, your objective very simple. I want to validate whether the law of demand is hold true or not. Very simple. Correct, no? Validate means what? You want to test whether the law of demand is hold true or not. When price reduces, the price of this mobile phone, reduces. What happened to demand? What happened to demand? Price reduces. What happened to demand? Demand increases. Correct? No. Correct? No. But that is based, don't say simply, based on the law of demand. I need to test it, whether it is the coefficient value is positive or negative. So you have an Excel sheet, you have a calculator. What do you do with that? Okay, then what is your objective? To find out. As per the theory, right? You know the theory. What is the theory? Demand, theory of demand. What says? The law of demand says, keeping other factor remains same. And when price reduces or price increases, what about demand? Price increases, demand, the quantity demand reduces. Correct? No. You want to validate it. That's the purpose. So what you will go for it? You go for simple. What analysis, madam, you want to go for it? Simple regression or correlation also will do. So either you can go for, so you should have a predetermined mind. How you get it? You go for the correlation or regression. Because it is already, what theory says. Or the statement of the theory, based on statement of the theory, or based on your logical way that you are put forth. Then only, okay, what is your objective? You want to find out the relationship. No, I want to find out the impact of price change in price on quantity demand. Then comes to your, the EViews. Okay. Then come to your tool I am talking about, which technique you are going to use. Correlation. You only said, madam, correlation. Okay, your purpose should be solved. Then use the calculator or use the computer to, EViews to execute the result, give the data, it will give the output. Madam, please, I am just correcting a flow. There is a flow. Having two data, why can't I try? Yeah, why can't I try? No, why can't I try? No, you understand? No, that question should not come. There is a flow. So you should have a lot of readings. What the theory says between the two variables, FDI and GDP. What are the arguments? Put forth the argument. Frame your objective. Based on objective, select the tools. How you will get an idea about the tool? Read the existing literature. What are the models they have implemented? On what basis they implemented? On what basis they implemented? The war is, I also thought that, yes, war, why we are using war? Mostly the war is used for finding out the causation, not only for the causation. The shock which is given to one variable, to check how the shock is react to the the other one through impulse response function. But the purpose is different. So here I am explaining to understand what is the purpose behind the VAR model. If you look at the different, see if I go with FDI and GDP, I'll apply VAR model to find out the causation. Whether the VAR is innovative or what is the advantage of VAR? That is bigger based on the gap. Based on the gap of the existing literature, you should come out. No, VAR I don't want to go with the OLS model. That's up to you. But you have to substitute. You have to come out how your research is unique in terms of existing. So I'm good at OLS. I don't want to go for VAR. No, sir. VAR is appropriate based on the theoretical sense or the logical statement. Yes, go for VAR. No, I'll go with the co-integration plus VEC model. Yes. No, I will go with the ARDL model, which is compared superior based on the sample size. Very good. Yes, you can go ahead. Which is superior than the joints and co-integration. Yes, fine. Up to you. You understand? No, so what I'm saying, go with the flow, like a logical. Identify your clearly. You should know the theory. You should read the article. Read your the nexus between the two variables. How they addressed it. Models comes later. Identify the objective, then you go with the flow. Like, okay, let me go with the stationarity test. Mine is very clear. To examine the causes nexus between the two variables. So you have in your mind VAR model, or you have in your mind your ARDL model. So everything decided based on the stationarity. Okay, but everything is based on the OLS framework only. As of now. OLS framework. Okay, so now we will go with the purpose. Objective should be very clear, please. Objective should be very clear. Sometimes, if you look at, Professor, you know that the ARDL is, maybe he has used yesterday while discussion, he has used. ARDL is used to just to find out the impact of one on another. The same ARDL is used for the causation as well. The long run and the short run. Purpose, objective. What is your objective? Should be very clear, whatever the topic you are taking. Sir, I want to see I have seen many studies, they want to find out the impact of macroeconomic variable on share price. Understand? Impact of macroeconomic variable, GDP, exchange rate, export, rate of interest, money supply. When the macroeconomic variable reacts, they want to see what are the changes takes place in the share price. Beautiful study. And mostly either they want to know, they have studied the impact of the macroeconomic determinants on share price, one side. The other side, they have studied causation. Whether the share price leads to the change in the share price leads to change in rate of interest. Sometimes a change in rate of interest leads to share. That kind of study also I have seen it in a bivariate, in a causation center. So please, the audience I want to know, please, I appreciate you people that you are showing a keen interest to learn the model. Yes, but model comes the middle part. Sender. So don't start with a model. But you are learning, you are enthusiasm, showing interest in learning the model, but don't go for it. First start with so one example, I'll tell you the reality. When I started my career with the PhD, my PhD topic is related to the derivatives market, which is with the futures and options, futures contract. But I'm not interested in it, but I am very much interested in the FIA, FIA, right? The foreign institutional investment. Still anyway, in the capital market only. Foreign institutional investment. I've done a beautiful research. How the FIA inflows, the foreign institutional influences the stock market returns. the FIA influences the stock market returns. Understand? No? There are many theory. I've studied many theories. Herding behavior also I have come across about the herding behavior. So the hypothesis put forth by Working. Working is a leading professor, eminent. We call it a working professor. Still, I could remember that word. Positive feedback hypothesis, negative feedback hypothesis. Beautiful. Why? Because sometimes this portfolio, 2008 recession right now. The 2008 recession, the foreign portfolio investment is one of the main reasons to create instability in the market. They withdraw the money all of a sudden, which the instability create the kind of, say, the trembleness or whatever. It created instability in the market. But that doesn't have a much impact on our Indian economy, 2008 crisis. But anyway, what I'm saying, I just worked on the FII. What is the problem? No. I want to extend that work. One is based on FII inflows. To go ahead with further, my analysis part, I couldn't able to get the industry-wise FII inflows. Please try to understand. Overall, FII, I'll get it. We call it as net FII. Inflows minus outflows. Beautiful. Yes, inflows minus net FII, I'll get it. Sales minus the risk. Sale minus the receipt. If you calculate, calculation, the sales minus receipt, or inflow and the outflow. So which I got, the FII, I could not able to, because PhD is not simply based on the aggregate value, the FII value. So what I have done, I'm looking for industry level. Don't say, sir, there is a prowess. You can try it. Yes, I have tried, but I'm getting a percentage, not actual value. So Bloomberg, I don't have. Cross-country level, I tried. I could not able to get still. And what I did, I got stuck. Sorry, you only said no. But I'm good at theory. Once, why I burned my finger is because, sir, I studied the theory. I have idea about the framework, the econometric. Yes, but before proceeding, I started with the data collection. What happened? When I'm collecting data, I could not able to get the data. I got stuck. I could not able to go further. Then there is no other go. I just changed. The beginning, actually, the initial. Not in the middle of the year. The beginning, because I showed a lot of interest to go for. Spend most time in the library and this. So I could able to change it and move towards the derivatives. Where I also got fascinated to the topic. Why? Because when I'm reading some articles, always, why you are inspiring with the topic, you have your own story, right? So I have my own story to how I got inspired by with respect to the derivative. That also I tried with options, with nearness, out of money, in the money, at the money, moneyness. A lot of struggle I have. Anyway, just I started with the derivatives of futures contract as price discovery concept. At the individual stock, almost 136 stock, different sector level, I have done it. A lot of effort I have put. So why I'm saying, madam, this one. So data availability is very important, but finalizing the model later. Once the data availability is there, to give more confidence, to give more mileage about more exploration on the more deep, will go more in deep with respect to the theory associated. Okay. Hope I don't know whether I addressed data, but tell me, madam. Yes, tell me. Definitely. A good topic. Yeah, it's a part of what I have discussed. Okay. No, no. Yeah. Same in the sense, the regression, through OLS. The causality is basically the framework which is estimated through the OLS approach. Hey, let him, no issues.
We can compare correlation and regression. But the under name of possibility is correlation.
Why aren't they then why
Causal is a term which will be explained by the, like with connected to the hypothesis testing. We are using the term causality one way, two way. Correct? No. Correct? No. Different term actually. You take range. Range. Range basically, if you ask range side, it is the maximum value minus the minimum value. Some people say it's a point to point. Somebody says the distance measure. What is the distance measure? Point to point. No, it's nothing but the difference is the range. Correct? No, difference is a term actually. The causality is a term which the OLS model is the technique. OLS is the technique or model which we are going to prove the causality. That's it. So short form we say causality test. That's it, nothing else. Okay. So look at the time. 1 o'clock. Huh? So what we'll do is we'll come back because if I start, it'll go in a flow like half an hour it will take to estimate it, to explain and estimate it. We'll go for lunch. We'll wind up for lunch. 2 o'clock we'll meet, and I will go straight away with the VAR model. Followed by VAR model, we go for the co-integration and vector error correction model. Fine, no?